Hello student, welcome to our physics discussion, that is physics in a smart way. You might have known, if not, now you know it, that in 11th and 12th, 3 or 4 major topics are there in addition to your mother language, mother tongue, English and all that. And those are physics, chemistry, math and biology. And usually the common notion is that physics is supposed to be the toughest, the most difficult of the subjects. But in fact, as you'll be going in to see, that is just fun. Physics at your level, that is 11th or 12th, as I say, and since 30 plus year, I am telling that to student, is nothing but your class 10 mathematics. Class 10 mathematics plus a bit of common sense. You add them, then you can handle with physics of any level at 11th, standard 11th or standard 12th. But when I say this, that is almost 90% true. 90% true. I have hidden the 10%. The 10% is that there is a bit of mathematics that is not usually taught at the class 10 level that we must know. That we must know, then the whole thing becomes complete. But mostly, mark my words, mostly your physics that will be learning at class 11th and 12th will be mathematics, dealing with mathematics of class 10 level plus common sense. You are not to leave out the common sense at any time. Sometimes students try to learn by memorizing some formulas and try to apply it. So for example, most of you might be knowing a body is moving on a straight line and with constant acceleration, there are several formulas like V equal to U plus AT, S equal to UT plus half AT square, then B square equal to U square plus twice S. So many formulas are there. The mistake that we do, that we try to memorize all those formulas and put in some data, try to find the result. Physics cannot be dealt with in that way. In that way, somehow that is a topic which require a bit of our brain. And when I say brain, we don't have to be a genius at the level of Albert Einstein, Erwin Schrödinger and all that. We have to just keep our common sense with us. That is enough. For most of the cases of physics, maybe at the board level, maybe at the entrance level. And when I talk of entrance level, we may go for the topmost, the toughest entrance at our level, our country, I'm sorry, that is JEE Advanced or IITs and whatever it is. Okay, some students start preparation from class 8, 9th, like that. But most of the things that they go through, I see those are crafts. The student need to be taught bit more mathematics, and that is enough. Learning physics or chemistry and other things at the school level may not be so useful at 11th and 12th because they become more logical. Rote learning doesn't matter, or rote learning won't help. But you know, some people do the business in that way. They lure the student and get their business, what we can say. So I am going for, and also the second issue is that there is a popular statement that mathematics is the language of physics. Physics expresses itself in terms of mathematics. When I say mathematics, that is 90% math at your class 10 level and 10% extra. And that 10% we are going to complete here. They are also essential. They are also They are also essential. They are also needed if we are going for a 100% coverage. When we talk of mathematics, that extra bit of mathematics that I brand it as applied mathematics, as applied mathematics, as applied mathematics, because we are going to apply that in your physics or physical chemistry or maybe in biology. Okay, it's basically in two parts. First part is coordinate geometry, geometry of XY coordinate, and second issue, second thing is calculus. It's calculus. Those things, coordinate geometry, somehow a small part of that you may have been aware at your school level, that will be going through. The calculus is completely new. Because that is completely new, I am going through it first. You know, the word is calculus, somehow it is linked with some calculations. We know every mathematics is linked to some calculation. I remember a thing at my 11th level, that is way back in 1978 or 79, 78 to be precise. People used to say in my mother tongue, they used to say calculus, aji न पढ़िले काली के loss. Most of you do not know my mother tongue, that is Odia. They used to say calculus, aji न पढ़िले calculus. Calculus, that means if you are required to study it every day. If you skip a day, then maybe next day you will be losing it. No, as I found out, the thing is not like that. That only creates a pure psychosis. In fact, you can skip it for 7 days. On the 8 days, you can start fresh, no problem. Okay. It consists of two parts. So far as calculus is there, it consists, or usually we divide it in two parts. One is differentiation, sorry, let me make it more legible. Differentiation, sometimes people say that as derivatives. Derivatives both mean the same thing. Derivatives. Second part is integration. It's integration. Sometimes people brand it as also integral calculus. As you promote yourself in your studies, you pass out 11th and 12th, go to higher courses in engineering or in pure science or to any branch of study, anything that you study that requires mathematics, those things will be further subdivided. Many new branches will be coming up within them, like operator algebra and all that. But at present, the topic of calculus for you is only two parts. One is differentiation, other is integration. And usually these two are two operation procedures, mathematical operations like addition, subtraction, we may take multiplication and division. Those are mathematical operations. These also are mathematical operations, but usually their very nature is in such a way that they are opposite. Just like multiplication and division, we know they are both operators, but multiplication most often increases the value and division decreases the value. They are opposite procedures. Similarly, addition and subtraction, they are opposite procedures, opposite operations. So similarly, differentiation and integration, they are seen to be opposite procedures. When somebody takes differentiation, normally people say, popularity say, differentiation makes 1 to go from goes from whole to part, and integration that makes one to go from part to whole, part to whole. To be more clear, when we say one goes from whole to part, whole doesn't mean complete universe or something like that. That means for a big thing to a very small thing. Just like I got a piece of bread, I only take a small speck out of it. So from the whole bread, I consider a small corner or a small part. Okay, that is going from whole to part, going from a big thing to a small thing. And integration makes one to go from part to whole, means addition of the small things to arrive at the big thing again. So they are the procedures in calculus. So because we see derivative makes one to go from whole to part, integration makes one to go from part to whole. So it is easily you can see they are opposite procedures. How they are opposite, what do they mean? Let us discuss them in details. I will be trying to give you some detailed procedures, the whole thing in a more detailed way. So if number of videos becomes long, do not skip it. Do not skip it. Sometimes some of you might be impatient. You may be tending to skip it and go to a video in physics, but that will be detrimental. That will be harmful. Without knowing the tool, without knowing the weapon, we cannot go to a warfare. That will be just like that. Okay, you have to have the weapon. We have to have ourselves trained in those. Then you can go to a warlike situation. And now you know your 11th and 12th, and just after 12th, you are go to a warlike situation like succeeding in entrance, all of those things. So basically it's a warfare. Basically it's a battle of wits. Okay, and these things are our tools which will be using them. So we go for the complete explanation of them. But before that, let me remove the space so that we can be able to write something. I can be able to elaborate it. Because calculus consists of two parts. One is differentiation, other is integration. Naturally, your idea must be that teacher will be considering one part first, then go to second part. I won't be doing that. I'll be mixing up the two parts. So thereby, why I will be trying to mix that? Our idea will be fast, learning will be fast, and they are intrinsically involved with each other. If you skip one and go for the first and then go for the second, that takes us bit longer in time, and that is not necessary alone. And if we mix it, then no harm will be done. Rather, we'll be more involved in the issues. So, but first of all, I'll be taking up the first, that is derivative. Integration will be coming in automatically within that. I have prepared a diagram for you. As you can see in the diagram, that is the diagram of coordinate axis, x-axis, y-axis, and you can clearly see there is an object lying on x-axis. If I ask you, and it is that, what do you think the thing is? Some of you may be saying it's a stick-like thing. Some of you may be putting in an idea, having idea that it's a tape-like thing. Some of you may be having some different ideas. And whatever your idea may be, that doesn't matter, those will be valid. Basically, and some of you may consider, we are selecting a particular space on the x-axis. Okay, that also is true. It may be a stick, it may be a tape, or a particular space we have painted on the x-axis. All are true. Any idea can help you. If I ask you, think of its length, then immediately you will be tempted to put it, the length, with a symbol that is L, maybe capital letter, maybe small letter. But that was, or that is mostly useful, maybe we can say valid, of course. Now it is not invalid, but those are your ideas at your school level. If you want to make it more scientific, then a student can talk in terms of coordinates. He or she can see, that the object starts with starting point has got a x coordinate, that is x1, and ending point has got a x coordinate, that is x2. So the length of the object, he or she may say, that is x2 minus x1. Yes, it may be slightly irritating for us, but that is the most scientific way. And that is usually written in short as delta x. We put a prefix delta in front of x, and delta means difference, because you are having a difference of x, x2 minus x1, ending x value minus beginning x value. I think I am clear. That is the most scientific way to put it. To put the length of the object that you see on the x-axis. And because we are in physics, our idea must be perfectly logical, perfectly scientific. Nothing unscientific will work here. Okay, I think you got the idea of writing delta x. Delta as a prefix, it acts as a difference. If I say delta t, usually t refers to time. So that must be, I am talking of a time interval, a final time minus initial time. If my event starts at a time t1, maybe sometime before the starting of the event, we make our stopwatch on. When the event starts, already in the stopwatch we see time t1 has elapsed. When the event ends, we put time as t2. So the time span of the event is delta t. That is the difference of two times. So similarly, our object, we know that is delta x, that is x2 minus x1. If I request you one thing that may sound a bit bizarre, and the thing is that you reduce the length of the object. And reduction can be done in many ways. You can do the reduction in many ways. If the object is flexible or pliable, like a rubberized thing or like that, you may shift x1, you may shift this end into the object. You may bring the other end in, so thereby the length will be decreasing. Some of us might be having an idea like cutting down some length of it. They can say, yes sir, you are talking of a smaller delta x. Now we are showing you the small delta x. We have curtailed or cut off the length. But I won't be satisfied. My next request will be, you try to find a still smaller length. At the same time, another request goes in always that whatever length you are finding out, whatever piece you are finding out, you have to measure it. So we'll be having a measuring scale, normal student scale with that. So if you are asked to decrease delta x, then you may be chopping off the ends and decrease it. Still, I am not satisfied. I ask you, no, you reduce it. So reducing it and it, you will be coming to a delta x, where delta x, I cannot write it because my pen, my marker has got certain limitations. So you will be creating a delta x, which is very fine. And because the last measurement that you can do with your student scale is 1 millimeter, so you'll be coming down. You will be coming down for me if you try to obey my request every time. That is of a delta x, which is 1 millimeter length, but I am not satisfied. No, I want a still smaller delta x. So then you'll be raising your hands, sir, we cannot do anything. I'll be suggesting there are two instruments which are useful in finding out very fine lengths, and those will be learning at your college level, that is at the 11th level. One of the instrument is known as slide calipers. Slide calipers. Second is screw gauge. Second is screw gauge. With the help of that, we can be subdividing 1 millimeter. You know, your school scale or the student scale has got a least count of the minimum. Say the measurement you can do is 1 millimeter. But if I use that instrument, slide calipers, I can go to 1/10 millimeter. A millimeter can be subdivided. If I go to a screw gauge, it can give us a length that is 1/100 millimeter. 1/100 millimeter. So then you will be trying to train yourself with these instruments. Ultimately, you'll be trying to show me a length which is 1/100 millimeter. Still, I am not satisfied. So if I am not satisfied, you might have been exasperated, but if the demand is persistence and you are not allowed to go scot-free, you'll be searching for new instruments which can go to a finer length, which is less fine or less than 1/100 millimeter. Then you can go for an instrument which is known as a traveling microscope. A traveling microscope can go very easily to a length of 1/1000 millimeter. It can measure. Then you may be utilizing that and you'll be trying to show me a piece which is having a length of 1/1000 millimeter. Okay, we are considering a thought experiment. If I am not satisfied, then, and if the demand is that delta x needs to be more fine, then the need will be coming in for more sophisticated instruments like electron microscope, which can give you a length which is less than a micron. If I am not satisfied, then the ultimate instrument you can consider is atomic force microscope, which can give you a length which is as small as 10 to the power -9, a nanometer. But if I am not satisfied, then you raise your hands. आप बोलेंगे, you will say, sir, we are lost, we are defeated, we cannot do anything else, because ultimately we have gone to the finest instrument available to the human being, that is an atomic force microscope. So at that stage, you have to stop because you cannot measure. But if our length is still smaller, then you come down to a level that is known as angstrom. And angstrom is 10 to the power -10. That is nearly the size of an atom. If I am not satisfied, then you may come down to the size of a nucleus. I think you know about a nucleus. All those things are taught to you at your school level. The nucleus is at a scale that is known as a Fermi or femtometer, that is 10 to the power -15 meter. Very, very small, ultra small. We have not been able to see it. We have not been able to separate it. That is so small. Our instruments have not gone down to that level. Okay, but if I demand a length still smaller than that, then you know the length is almost impossible. We can say very close to zero or nearly equal to zero. We are talking of those lengths which are infinitely small, infinitely small. They are so smaller, they are beyond the scope of our physical measurements. Okay? In mathematics, those things are written in a peculiar way because I have started with derivatives. But before starting with the derivatives, your mathematics demands that I must make you learn or you must be having the idea of other topics like continuity, limits, and all that. Then you can limits, differentiability, and all those things. But you know, we do not have got so much of time with a limited number of videos, maximum maybe 7 to 10. We have to have the idea, and we are not going to take here the entire course of mathematics here. That is second year mathematics. Your math teachers will be angry. Okay, that is not my purview also. Okay, but already we got a fair idea. We are talking of a length which is very small, very small, maybe a trillionth part thickness of a human hair or something like that. In mathematics, they have got a style. They write it in a style. Limit. They say limit delta x is so small, or the length is so small that tends to zero. Mark my words. Delta x equal to zero, that means delta x doesn't exist. But delta L tending to be zero, that means delta x is there. Delta x, it exists, but it is so small, we cannot measure it. Under that condition, the mathematics people, they say delta x is to be written as dx. That is their style. That is their style. That delta x is written as dx. Okay. 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 So thereby, I think you got it. So the people in, so this is usually a mathematical style of writing it. You should not question it. That is the norm. Just like why this is x-axis, why this is not y-axis. It's just a convention. Okay, writing anything very small as dx. If I write a thing as dt, and if t refers to time, then dt should be a very small time, which is almost immeasurable. That is less than a nanosecond, less than a time that is 10 to the minus 15 second. Time exists. This is a time interval. It exists, but we cannot be able to measure it. Okay. Similarly, if somebody writing dA, if A refers to area, then that is so small. There is an area. It is so small that the area almost it approaches zero. Just like a geometric point. We have learned about the geometric point in Euclidean geometry at our school level, and usually our teachers define a point as a thing that exists but has got no spread. Then it can be perfectly referred as dA. Okay? And the people in mathematics, they are so lazy, they do not write the full word limit. They remove the last two letters. They only write lim. But once you see the word lim, we must know that is limit. They write it lim, our delta x tends to zero, then delta x becomes dx. Okay, I think I am clear. Let me remove the space, clear up some space. Sorry. गरम कर दिया खा. So we got the idea. Now, if I ask you now that let us imagine dividing the entire length of hour in our diagram into such dx, 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 dx like things. So you divide, let us assume that we are able to divide. The first dx will be branded as dx1, the second dx will be dx2, the third dx will be dx3, the last dx as dxn. But one thing, there is a difficulty. dx1, it is almost indistinguishable from dx2. dx is so small, it is very difficult to distinguish. It is very difficult to distinguish from one from another. Okay, if you keep several such dx at your palm, even if your breath will be blowing away some of them, and you won't be able to visualize, you won't be able to sense it. So if you divide the entire length into such dx, 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 dx like things, okay, dx1, dx2, dx3, dx4, dx5, last one is dxn, then you are dividing it to n number of parts, then we can say our length delta x is divided into, if we assume that all dx's are equal in length, n different dx's. Now try to imagine how much that quantity n will be. What will be the value of n? Of course, we are having a difficulty. I have not told you exactly how much delta x was, whether delta x was 2 meter or 10 meter or 3 kilometer or 5 centimeter. But you have to imagine dx is a very, very small length. Regardless of the value of delta x, if you divide into dx, the number of divisions will be very, very large and almost approach infinite. Okay, in mathematics, that is usually expressed in terms of integration that uses a peculiar sign. This sign, as you can see, has got a long midsection, but that is derived from the letter S. S means summa in Latin or in Greek, I don't remember exactly. Summa means a summation. Summation, that is known as a integration sign. Integration of dx will be equal to delta x. Integration of dx will be equal to delta x. There is some difficulty in this also. I don't want to elaborate, but I think you got my idea. So integration of dx means the summation of dx. dx1 plus dx2 plus dx3 plus dx4. Okay, you can write it at the left hand side. You don't have got enough space. dx1 plus dx2 plus dx3 dot 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 up to the last dx, that is dxn. Okay, in short, we say that is integral of dx or integration of dx, that is delta x. There is a small difficulty in it, which we'll be discussing in the next video, today's video. Otherwise, today's video will be very long. So today, I must bid goodbye to you. That's all. In my next video, we'll be continuing our discussion. But before coming to my next video, you must have a brief look at the things that we have discussed before. So thereby, without any loss in comprehension, without any loss in continuity, we will be getting to the things very easily. So thank you. Let me end here. Goodbye for today.